Hello, my name is Kirsten Smith, and this is my science fair project on astrophotography filters. Can narrowband filters help differentiate between different gases and negate the effects of light pollution? My hypothesis is that if I use narrowband filters, then it will improve my ability to be able to photograph deep space objects with the telescope by filtering out light pollution and light outside of the spectrum that the filters allow to pass through. Procedure. First, you set up the telescope and hook it up to the computer that will be used to control the telescope. Next, you align the telescope to Polaris, the North Star, so that the telescope will track the sky correctly as the Earth rotates. Then you find a bright star to focus the telescope on. Next, you program the target into the computer and position the target in the frames the way you want it. Finally, you select the filter and set the exposure time to take long exposure photographs of the target. If it is windy outside, it will move the telescope and make the images blurry. Clouds make it impossible to see the night sky. Also, high humidity and high pollen will also negatively affect your ability to take photos. The optimal conditions are clear skies, dry air, low pollen, and calm weather. Data. The Rosetta Nebula is part of the constellation Monoceros and is also known as Caldwell 49 SH2-275, which is what the Rosetta Nebula is cataloged as. The Rosetta Nebula is approximately 5,219 light years away from Earth, and its size is 65 light years. The Rosetta's magnitude is 9.0. Magnitude in astronomical terms is the measure of how bright a star or other form of celestial body. The brighter the star of the celestial body, the lower the number of magnitude. Different filters allow only a narrow band of light to pass through the filter in order to target specific gases in the photo. For example, SII only allows a certain spectrum of light to pass through the filter. This spectrum of light is reflected by sulfur.
Okay.
Conclusion. I concluded that my hypothesis is correct because with further research, I learned that narrowband filters only let a certain spectrum of light come through to the camera. This not only helps with light pollution, but it singles out certain gases that emit or reflect light on specific spectrums, making it possible to photograph only that gas within the nebula. The nebula I chose, the Rosetta Nebula, emits light. This photo is HA, hydrogen. It's the brightest gas in the nebula. This photo is OIII, which stands for oxygen. It is the second brightest gas in the nebula. This photo is SII sulfur. It is the least bright gas in the nebula and the least present. These two photos are false color composite images, combining the photos of the individual gases assigned to different color channels of red, green, and blue. HOO palette. Red is hydrogen, green is oxygen, and blue is oxygen. The Hubble palette is red, sulfur, green is hydrogen, and blue is oxygen. Sources. My sources were nasa.gov, astrobackyard.com, and botanica.com. My materials were the telescope, William Optics Zenith Star 73. Camera was ZWO ASI 1600mm. Narrowband filters, HASII and OIII. We use an HP laptop and a tracking telescope mount.